Okay, so today we're going over the chapter 5, the for the tree geometric. So 5.1, first section for the chapter 5 is the unit circle. The unit circle. Okay. 5.1 unit circle. First of all, we have to define what is the meaning of the unit circle. So here, the unit circle is a circle of radius 1, radius 1, and center 0, 0, the origin 0. Okay, so as we learned before in the first chapter, I think, the equation of the units of the circle. So the equation of the circle is x squared x minus x0. So the equation, who will remind me for the equation of the circle? What is the equation of the circle? What is the equation?
It's x minus h squared
Okay.
plus y minus k squared.
Y minus what? K?
Yeah, k.
Okay. Equal what?
Equals radius squared.
Okay, perfect. What is h and k? What is the h and k?
This
Center. Center, right? So for the unit circle, I have a radius equal 1, and my center is the origin. The center is 0, 0. So I'm going to plug these things inside the equation of the circle.
Good evening. Professor, could you send the attendance sheet again? Sorry.
Okay. So the radius is 1 and the center is 0, 0. So we're going to plug these things inside the equation of the circle. So now my unit circle equation is x minus 0 squared plus y minus 0 squared equal 1 squared. So the equation of the circle, of the unit circle, is x squared plus y squared equal 1. So this is my this is the equation of the unit circle. This is my equation of the unit circle. X squared plus y squared equal 1. Thank you, Angel. So this is the equation of my unit circle. Okay, now this is like review. My important things now is to show that any point is in the unit circle. So first example, show the point so first example is So this is example 1. Show the point. This is the point here. Is b of the square root of 3 over 3, comma, square root of 6 over 3. Show this point. This point is in the unit circle. This is the first example. So how can I show this point it's in the unit circle? How can I show this point is in the unit circle?
It's in the equation you gave us.
What we said?
Yes, in the equation you gave us. S squared plus y squared equals 1.
Exactly. So I have to plug this point inside the unit circle equation. My unit circle equation is x squared plus y squared equal 1. So I have to plug these things inside the equation of the unit circle and to check is the answer is 1. If the answer is 1, this is mean this point it's in the unit circle. So let's plug it. So the first point is x is the square root of 3 over 3 square plus the y point is the square root of 6 over 3 square. And the answer is the square root of 3 is over 3, everything square is 3 over 9 plus the square root of 6 over 3, everything square is 6 over 9, and 6 plus 3 is 6. 3 plus 6 over 9, they give me 9 over 9. And 9 over 9 is 1. This is mean this point are on the unit circle because the answer is 1. This is mean the point, this 2 points, this point, it's sitting on the unit circle. Any question? Anyone has a question? Okay, example 2. So I give you a point. The point is b and of square root of 3 over 2, comma y. The point is on the unit circle in the quadrant 4. The question is find the y coordinate. So my question is find this y coordinate. And they told me this point it's in the unit circle. How can I find the y coordinate since this point is sitting in the unit circle and it's found in the quadrant 4. So let me graph the unit circle. So this is my unit circle here. It's my unit circle. The radius is 1, and this point it's in the 4th quadrant. So this 1, 2, 3, 4 here. So it's here, for example. So this point square root of 3 over 2, comma y. The question is find y. So Angel, he said y equal 1 over 4. How we find it? Can you explain?
So I substitute that value into the circle formula. Then I just square it, everything will be 3 over 4.
Okay.
Plus y squared equals 1. Then I isolate the y, subtract 2. Oh, wait, I forgot something. I'm sorry.
Okay. This is true. So he said I used also again the union square equation. It's x squared plus y squared equal 1. And he plugged this point inside the equation. So when he plugged this point inside the equation is the square root of 3 over 2, everything square, plus y squared, because I need to find this y, equal 1. And he solved this equation by subtracting this element from both sides. So I get y squared equal 1 minus this point, it's 3 over 4. So he got y squared equal 1 minus 3 over 4, it's 1 over 4, because 1, it's actually 4 over 4. So 4 over 4 minus 3 over 4, it's 1 over 4. Okay, exactly, Angel. He take the square root from the both side. So now, so here he subtract 3 over 4 from both sides, and he get y squared equal 1 minus 3 over 4, y squared equal 1 over 4. He took the square root of the both side, so now he gets y equal positive negative 1 square root of 1 over 4, it's 1 over 2. Now, which value we have to use, the positive value or the negative value?
The negative value.
Negative, exactly. Why? Because the point, it's in the quadrant 4. So in the quadrant 4, the y value is negative. The value here is negative. So this is mean y is equal minus 1 over 4. 1 over 2. This is my y value. So here y equal negative 1 over 2. Why? Again, because the point, it's in the 4th quadrant. Any question? Anyone has a question? No. Okay, we don't. Okay, so this is the important two things about the unit circle. You have to know the equation, and you have to know how to show any point it's in the unit circle by plugging the point, and you check. If they give me 1, this means the point it's in the unit circle. The 1 means the point it's in the unit circle. Now here for the second example, they ask me what is the y coordinate. If they give me a point, what is the y coordinate? Again, we have to plug inside the unit circle, and then we have to check what is the possible value for the y. Okay, now let's go to the important things. Is the terminal point. It's called the terminal point on the unit circle. Yes. So now let's go to the terminal point. Terminal point on the unit circle. First of all, before we start talking about the terminal point, let's know what is the distance around the unit circle. This is my unit circle, and this unit circle is, like I said, has a radius 1 and center 0, 0. Suppose my starting point is this point, 1, 0, and I need to move around this circle like this, moving around this circle, walking in this circle, and starting from the point 1, 0, and coming back to the same point like this. My question is now, what's the distance for this unit circle? What is the distance if I starting from this point, moving around this circle, and return back to this the same point? Angel, he said 2 pi. This is true. This is right. So the distance, if I want to measure the distance for my unit circle, is 2 pi. How we find it? By something is called circumference. So by using the circumference, c equal 2 pi r, I can find the distance for this circle. So now in the unit circle, the r is 1. I plug this one inside the circumference, so I get c equal 2 pi times 1, and they give me 2 pi. So the distance around the unit circle is 2 pi. Okay? If I start from this point 1 and 0, moving around the unit circle, stop and return back to the same point, the distance 2 pi. Now my question is, what is the distance if I moving from 1.0 to this point here?
1 pi.
1 pi, exactly. So the distance for all the circle is 2 pi. The distance for the half circle, starting from this point, moving, stop up to this point here. The blue one is pi. The distance is pi. So the distance will be pi. Now, if I move from this point and I move around up to this point, what is the distance? It's pi over 2. Exactly. It's like the half of pi. The distance is half of pi over 2. Let me write it here. Here, this point is pi over 2. So now we know what's the distance for the unit circle for the like when I move from this point for all the circle. When I move to the half of the circle, what is the distance? And the same things if I move from this point to this point, I know what's the distance. So in general, the distance for the unit circle is 2 pi. This is what you have to know. The distance is 2 pi. Here 2 pi. We still did not talk about angles. I'm just talking about distance. Okay. Now I'm going to define something is called t. So here, what is the t? So I have t. This t belongs to real numbers. Now, if t is positive, so let me define it as here. So t is real numbers. If t is positive, and I'm going to define t if t is negative. Okay. So first of all, t is like any real number. T belongs to the real numbers. Now, if t is positive, greater than 0, here, we're starting at the point 1, 0, turn counterclockwise around the unit circle, like this side. Counterclockwise means moving like this. If this is my unit circle, here, I'm moving like this. Counterclockwise around the unit circle, with distance is t. The point where we stop at this, where we stop at, is calling the terminal point. So now we can define what is the mean of terminal point by using t, real number. If t is negative, the same things exactly, but the difference is the direction. We're starting at the point 1, 0, this point. We turn clockwise. Clockwise means, move this down. Clockwise means like that. Here, counterclockwise means like this. Like this. So we're starting at this point, 1 and 0, moving clockwise, like the clock, around the unit circle with distance t, the absolute value for t. Why the absolute value for t? Because t is negative. So this is the absolute value for t. I need the positive only. The point you stop at is calling the terminal point. Same things. So let me graph some pictures and explain how to find the terminal point. So example. Okay, so for this graphs, okay. Okay, here's the unit circle. So suppose my t, I said t, it's a real numbers. T is positive or negative. The positive and negative means the direction. If it's positive, I move around the unit circle counterclockwise. But if t is negative, I move around the circle clockwise. The t is the distance. T is the distance. So my question here, suppose my t, for the first one, t is equal pi over 2. So here t equal pi over 2. This means, first of all, t is positive here, is greater than 0. So t here is greater than 0. And t is the distance. So I have to move around this circle, starting from this point. This is my first point, 1 and 0. Move around this circle for distance pi over 2. Like I said here, the distance pi over 2, starting from this point up to this point. So, and it's positive, this is mean we have to move counterclockwise like this. Okay, something like this. Because it's positive, so I have start from this point, I'm moving around the unit circle up to here. I stop at up to here. Now this point, let me put it in different color. This point here is called my terminal point. And the point here is 0 and 1. So my terminal point for t equal pi over 2 is 0 and 1. Any question? Counterclockwise because t is positive. Any question for the first one? Okay, now, if my question is for t, how do you know how much unit to move by? Like I explained here. I said if I move from this point around all the circle is 2 pi. If I move from this point around the half of the circle is dividing this by 2, it's pi. If I move from this point to this point, the yellow one is dividing the pi by 2, or pi over 2. So the distance from here to here is pi over 2. How I find this, how I find the distance for the unit circle by using the circumference. The circumference equal to pi equal times r, and r here is 1. So I get 2 pi times 1 equal 2 pi. So for t equal pi over 2 is done. Now for t equal pi. So first of all, t is positive. So it's greater than 0. This is mean by using here t is greater than, starting at this point, turn counterclockwise. Unit around the unit circle with distance t. So my distance is pi. Can you explain pi over 2? Yes, again, yes. So for t equal pi over 2 again, the distance is from here to here, and is greater than 0 is positive. So this is counterclockwise, moving like this. This one, this one, okay. So t belongs to the r. T is the distance. And if it's positive, okay. So now again, t is equal pi. The pi is greater than 0, is positive. Positive, go back here, t is positive, starting at the point, turn counterclockwise around the unit circle with distance t. Now the distance is pi. The pi, as you said, starting from this point, turn around the circle, the pi is stop up to here. This is the distance pi. How we know? By this circle. The all circles to pi, half of the circle is pi. So I stop up to here. This point here is my terminal point. So terminal point is this. Okay. This is my terminal point. And again, Here is my starting point, 1.0. So what is my terminal point? So my terminal point, it shows here. This point is 0 and 1. No, it's -1 and 0. -1 and 0. And again, I move counterclockwise because t here counterclockwise. Why? Because t is positive. Makes sense for the second one? Now, for t equal -pi, what is the terminal point? T equal -pi. So the negative, this negative, means the direction, clockwise, exactly. Starting from this point, and the distance, it's pi. So this is by half circle. Starting from this point, move around the circle, the unit circle, for distance pi. Stop up to here. This is the distance pi. The negative means the direction, clockwise, like this. Why? Because t is negative. Clockwise. Because t is negative. Now, this point here is called terminal point. What is it? The terminal point is -1 and 0. -1, 0. Any question? Okay, another example. I mean, like the same things. If I give you another one here, and my unit circle like this. For t equal 3 pi over 2, and another one for t equal -3 pi over 2. The question is find the terminal point. For this one, what is the 3 pi over 2? What is the distance? So the distance for 3 pi over 2, it's meaning we have to move around the circle 1 pi, then we have to move again like a quarter of the circle to get the 3 pi over 2. So this is my starting point, 1, 0, moving around the circle because it's positive. This means counterclockwise, moving like this, walk around this unit circle. And I arrive this point. This point, it's my terminal point. This distance is a 3 pi over 2. So this point here, it is my terminal point. What is my terminal point? Is 0, -1. because this point is 0 and -1. Why I move like this? Because the t is positive. So I'm moving like this because t is positive, counterclockwise. For this one, what does the negative mean?
Clockwise.
Clockwise. So starting from this point, moving it like distance 3 pi over 2, clockwise, for distance 3 pi over 2 is up to here. So this point here is my terminal point. So this is terminal point, and the point here is 0 because the x is 0 and y is 1. Why I move like this? Because the negative. Why? Because t is negative. Okay, any question? Is it clear? Okay. If you have a question, you can ask. So here is greater than 0. Here is negative. Now, there is some point is less than pi over 2. Some points, it's less than, I mean like some distance. This distance is, it's less than pi over 2. So this is my unit circle. And I said this point, this distance from starting from the 1.1 over 1 and 0, 1, 0, moving from this point to this point, this distance from here moving around the unit circle and to here, the distance is pi over 2. Now we have different distance. If the distance is, if I move up to here, this distance is pi over 6. Pi over 6. And if I want to keep continuing, there is another distance here is pi over 4. And if I want to keep continuing, there is another distance here is pi over 3. Okay, so from here to here, the distance is pi over 3. From here to here, the distance is pi over 4. From this point to this point, the distance is pi over 6. This point, it has like a special table. It has a special table, and this table you have to memorize it to know what is the terminal point. This table, you should to memorize it to find the terminal point. So the t and here the terminal. You don't have to know how to find it, just you have to memorize it. Point. So for example, if t is pi over 6, or let me start from the 0. The distance is pi over 6. The distance is pi over 4. And the distance pi over 3. And the last one is pi over 2. So now, for t equals 0, the terminal point always 1, 0. And for pi over 2, at this point, is 0, 1. For pi over 6 is square root of 3 over 2, 1/2. So the terminal point for this point, for the distance pi over 6, is the square root of 3 over 2, 1/2. The terminal point, if I start moving from this point to this point, is this thing. If I start moving from this point to this point, is 1 over square root of 2 over 1 over square root of 2. Yes, this is true, Angel. The same things. Now, if I'm moving from this point, moving around the unit circle, and I stop here, the terminal point here is 1/2, square root of 3 over 2. This table, you should to memorize it. You don't have to know how we find it. It's not, we don't have to prove how to find it, but you just know, you have to know how to memorize it. You know how you have to just memorize this table. Okay. Okay, so my question now, find the terminal points. Here, Angel, pi over 4 is square root of 2 over 2 square root of 2. Yes, but square root of 2 over 2 is the same as 1 over square root of 2. Why? Because
we cannot have a radical as a denominator.
well, but this the same like 1 over 2. How I find it? I multiply both sides by square root of 2, square root of 2. Square root of 2 times square root of 2 is 2 over 2 times square root of 2. The 2 with the 2 is done, so I get 1 over square root of 2. And this is easier to memorize, 1 over square root of 2. Okay? Or you can use the other one, whatever you like. It's fine. If you want to use like square root of 2 over 2, square root of 2 over 2 is the same as 1 over square root of 2. Explain what? These things? Knowing? Yes. So you have to know square root of 2 over 2 is the same as 1 over square root of 2. How? Because square root of 2 over 2 is by multiplying both sides by square root of 2, square root of 2. When I multiply the numerator and denominator for the same quantity, this means we don't change for the fraction. So square root times square root of 2, they give me 2 over 2 times square root of 2 is 2 square root of 2. We can simplify the 2 with the 2. Now they give me 1 over square root of 2. So this means the square root of 2 over 2 is the same 1 over square root of 2. What is the other method?
So everything is over 2 as a
Everything
fraction.
over.
Yes. Then I use the form, but we start as 1, then 2, then 3. Then I go back down and from the
Oh, okay.
there's value, and then the y value will go 1, 2, and then 3. And every value that is now 1 we square it.
Nice. So he said 1 and 2 and 3, I think. 1,
Yes.
2, oh yeah, 1, 2, 3. And he
And
said 1,
down back.
2, 3. Yes, it's nice.
And everything that is now 1 we square it
Yeah,
with the
this is
square
nice.
root.
Yeah, he has a good idea to memorize it. Like he said, 3, 2, 1. And here 1, 2, 3. Nice. Okay. So my example now, find the terminal point for pi over 6 5 pi over 6 minus pi over 6 7 pi over 6. So find the terminal point for pi over 6, 5 pi over 6 minus pi over 6, 7 pi over 6. So I'm going to do the first ones. I explain how to find it. So t equal pi over 6. So I graph the unit circle. This is my unit circle. And pi over 6 is like around here. Starting moving from this point, 1, 0, up to this point. This point is the t here. This point here is 1, 0. And the distance here t equal pi over 6. This point from the table for t equal pi over 6 is given like this. The square root of 3 over 2, 1 over 2. So I can set the terminal point from the table is from the table square root of 3 over 2, 1/2. So this point here is square root of 3 over 2, 1/2. This is from the table direct. Number 2. 5 pi over 6. 5 pi over 6. So for the t equal 5 pi over 6, the point will be like this. Here's my unit circle. 5 pi over 6, it's gonna be like in the second quadrant. Why? Because this point is pi, and pi equal 6 pi over 6. So this point is 6 pi over 6. This point here is pi over 2. And this is equal actually 3 pi over 6. This point is 0 if I start from here up to 2 pi. And 2 pi is actually 12 pi over 6. So the 0.5 pi over 6 is between 3 pi over 6 and 6 pi over 6. So the 0.5 pi over 6 will be like around here. So this means I start moving from this point around the unit circle up to here. This is t equal 5 pi over 6. We should to know the 5 pi over 6 has a terminal point is exactly like t equal pi over 6, but like this point. But the difference is the sign for the point. So the t equal 5 pi over 6 has a terminal point like this, exactly like t equal pi over 6 is square root of 3 over 2 comma 1/2, but the difference is the sign. For the second quadrant, the sign for the x value is negative. So here we have to write it negative here. So here is negative. And for the y value is positive, so positive. Sign change in each quadrant, exactly angle. So the square root of 3 over 2 and 1/2. So again, the terminal point for this t is exactly like t equal pi over 6, but the difference it's the sign for this point. So the sign here it will be like negative because the x value here is negative and the y value is positive. So negative x square root of 3 over 2 and positive 1/2. Any question? Any question? So my terminal point is B, defined like this. So this is my B. And here is my B. Any question? Do you have any question? In here, this is my terminal point. Okay, for the third one, negative pi over 6. So negative pi over 6. For 3, t equal negative pi over 6. So first of all, we have to know the negative is for the direction. When you see t and negative, negative for the direction. The direction here is, what is the mean of negative? Again, what is the direction? Counterclockwise. Counterclockwise, exactly. So the t here moving like this. And the distance, it's pi over 6. So this means we have to move around the circle. This is my starting point. Moving for distance pi over 6. Like around here. This is the distance pi over 6. So my terminal point will be like this here. My terminal point is here. This is my terminal point. You have to know this point has a terminal point exactly like pi over 6. Like this. But the difference, it's the sign of the x coordinate or in the y coordinate or in the both of them. So the terminal point B, this is B, is the same as like before, square root of 3 over 2 and 1/2, but the difference is in the sign. So in the fourth quadrant, the x coordinate is positive because this value is positive, so here positive, and the y coordinate, so this is positive here, the y coordinate, it's negative, so negative. So the terminal point will be like the positive x square root of 3 over 2 and the negative 1/2. Any question? Any question? Now for the fourth one, 7 pi over 6. Here is my unit circle again. This is my unit circle. Now, again, I said this point is 0. This point is pi over 2. Or this is equal actually 3 pi over 6. This point here is 6 pi over 6 is the same as pi. This point is 3 pi over 2, 3 pi over 2, and this is actually equal 9 pi over 6. And this point is 2 pi if you go back again, and this is equal 12 pi over 6. So for fourth one, t equal 7 pi over 6. So 7 pi over 6 means we have, first of all, is positive. Positive means we have to move around the circle counterclockwise. So starting from this point, moving around the circle counterclockwise with distance is 7 pi over 6. The 7 pi over 6 is between here 6 pi over 6 and 9 pi over 6. So the 7 pi over 6 will be like around here. And we're moving from the first point, starting point, this is my starting point, around the unit circle, and I stop up to this point. This is my unit circle. Stop up to this point. This point here, this here, is my terminal point P. So the terminal point, the same as pi over 6, but the difference, it's in the sign. The terminal point B is square root of 3 over 2 and 1/2. And in this coordinate, the x is negative and the y is -2. So the value is negative square root of 3 over 2 and square 1/2. Any question? Anyone has a question? Is it clear how to find the terminal point? Okay. So now let me give you exercise. So here, exercise. The question is find the terminal point for t equal pi over 4. Number 2, t equal minus pi over 4. Number 3, t equal 3 pi over 4. Number 4, t equal minus 3 pi over 4. So if you know the original one in the first quadrant, you can know whatever for each quadrant. This is the important idea, how to find the terminal point for something like this. You have to find the terminal point for the first quadrant, then you can find any terminal point for the other quadrant. So this is exercise for you. Okay, any question about the exercise? Is clear? Okay, let's now go to the, if it's clear, let's go to the reference number. Something new is called the reference number. So let me give you the definition for the reference numbers. So here, yeah, for the first one is the square root of 2 over 2. Exactly, this is the first one. The same things for the other, but the difference is the sign. So the other is the same things, but you have to find the sign. Now we're going to the reference number. We don't talk about angles. We don't talk about any angles. So now, what is the reference number? Is the shortest distance along the unit circle between the terminal point and the x-axis. This is the definition of the reference number. Okay, again, it's the shortest distance between the unit circle, the terminal point, and the x-axis. Okay. Let me explain it more. Suppose, so right now we know what's the terminal point. We know what is the unit circle. So we can now find the reference number. So suppose I have a circle like this. So for the first one, suppose I'm moving from this circle, starting from this point, moving up to here. And my T here is this, the blue one. So now to find the reference number is the smallest distance between the terminal point. Suppose my terminal point is this. Here's my terminal point. So the smallest distance between the terminal point and the x-axis. And this is my x-axis. So the smallest distance between the terminal point and the x-axis along the unit circle. So the distance will be like this. So this is mean my T is exactly like my terminal point. So this is equal exactly to my reference number, sorry. So here reference number, I want going to define it like T bar, like this. So T here is the same like T bar because the smallest distance from this point to the x-axis is the same as T. For the second one, so here is the one. For the second one, suppose T like this, moving around the unit circle, and I stop up to here. This is my T. So what is now the reference number? The reference number is the smallest distance between the terminal point, this is my terminal point, and the x-axis. Here's again my x-axis. So the smallest distance between the terminal point and the x-axis is this distance. So this is my T bar. So this is my T bar. Let me use different color. So this is my T bar. And here is, this is my T bar. This one. Okay? Is it clear for the first one and second one? Is the smallest distance between the point, terminal point, and the x-axis. This distance. This is my T bar. For the third one, suppose the point starting from this point, moving around the unit circle, like this, and stop up to here. So the point, the terminal point is this point. the question is, where is the reference number? The reference number again is the shortest distance between the x-axis. This is my x-axis. And the terminal point. This is my terminal point. So the shortest distance between the x-axis and the terminal point is this. So this is my t-bar. Yes, I can go back. So this is t, and t-bar is from here to here. Okay. So this is my t-bar. Is the distance between the x-axis and the terminal point, the smallest distance. For the fourth one, suppose I'm moving around the circle like this. And I stop up to here. What is the reference number? And again, this is my terminal point where I stop. Again, the reference number, exactly, Angie, is the distance between here, the x-axis, and the terminal point. This is my t-bar. And this is my t, the blue one. So now, the example is, after we know what's the mean of the terminal point, my question is, find the reference number for each of the following. So example, find the reference number for each value. For the first one, t equal 5 pi over 6. Second one, t equal 7 pi over 4. 3, t equal minus 2 pi over 3. So to find the first reference number, I have to graph the unit circle to see what is the reference number exactly. So for the first one, 5 pi over 6 will be in the second quadrant. Why? Because by using this here, where's pi over this one? Moving from this point up to this point. Why pi over 6 in the second quadrant? Because it's between 3 pi over 6 and 6 pi over 6. So this means moving from this point around the unit circle up to this point. So my terminal point is here. To find the reference number is the distance between the x-axis here and the terminal point. This is my t-bar. How to find it? This point, actually, like Angel, he said, 2 pi, this is pi over 2. This is pi over 2. I mean like pi, sorry. And this is equal 6 pi over 6. So we subtract this point here from this point. So t bar equals 6 pi over 6 minus 5 pi over 6. And the distance is pi over 6. And this is my t bar. For the second one, the same idea exactly, same idea. So we're going to graph. So I'm going to graph. Let me erase this one. I'm going to in the back. So let me graph. This is the graph. Here's my unit circle. We move around this unit circle 7 pi over 2, like this. Starting from this point, moving like 7 pi over 2. Up to here. Why here? Because this point is 2 pi. This is actually equal 8 pi over 4. And this point here, this is 3 pi over 2, and this is actually equals 6 pi over 4. So the 7 pi over 4 will be like around between this point and this point. So my terminal point is here. Now the smallest distance between the terminal point and the x-axis is this. So this is my t bar. So the t bar equal the distance between this point, starting point, and the terminal point. The starting point is 8 pi over 4. Minus the terminal point here. Here is minus t because t is 7 pi over 4. 7 pi over 4. And t bar is equal pi over 4. Any question? Anyone has a question? Is it clear? Is it clear? 1 and 2? Okay. Now, by using the reference number, we're going to find the terminal point. Here is the steps. Now I can find the terminal point by using the reference number. And here is the steps. Okay, let me explain the steps. So using the reference number to find the terminal point. And this is very important. Okay. Steps. Find this reference number t bar. This is the first step. You find the t bar. Find the terminal point B determined by t. I mean, here you have to find the terminal point Q. Let me fix it. So this is the Q determined by t bar. Then the terminal point determined by t is the point B equal plus negative A comma plus negative B. I'm going to explain that by example, where the signs are chosen according to the quadrant. Okay, let me do an example, and I do it step by step how to find the terminal point by using the reference point. So the question is, find the terminal point for 1 t equal 5 pi over 6 . Number 2 is pi over, let me do the 1 by 1. So here the t is 5 pi over 6. First of all, we have to find the t bar. So the t bar by using the previous example, t is equal 5 pi over 6. The t bar is pi over 6 equal pi over 6. How I know? By this example. So t bar equal pi over 6. The terminal point for t bar is from the table. Go back to the table. Pi over 6 is square root of 3 over 2 and 1/2 is square root of 3 over 2 and 1/2. Now the question is, find the terminal point for t, not for t bar. So the terminal point for t is the same like this one, but the difference is the sign. How can I know the sign? I have to graph. So I graph, and this is my unit circle. And again, I start from this point, turn around. It's 5 pi over 6, like the second quadrant. Start from this point, move around, stop up to here. This is my terminal point. So the terminal point is B. Is the same like this point, but the difference is the sign. So in this side, the x-axis is negative and the y-axis is positive. So the point is negative square root of 3 over 2 and positive 1/2. So again, let me explain it. You find the terminal point for t bar and the terminal point for t is the same like t bar, but the difference is the sign. Is it clear, this one? Any question?
Yeah.
Okay, next one. If t is equal 7 pi over 4, so you have to find the t bar, and from t bar I can find the terminal point. I can find the terminal point for t bar, then I connect it to the t. So 7 pi over 4, like I did it here, 7 pi over 4, it's in the fourth quadrant, and t bar is pi over 4. So t bar from previous example equal pi over 4. The terminal point for t bar is from the table. Go back to the table. Here, pi over 4 is the square root of 2 over 2 and square root of 2 over 2, or 1 over square root of 2, comma 1 over square root of 2. So is 1 over square root of 2, comma 1 over square root of 2. Now, for t, this is for t bar, the terminal point for t is the same like this one, but the difference is the sign. So the point starting moving from this point around the unit circle up to here. This is my unit circle, stop up to here. This is t bar. And this is t. So in the fourth quadrant, the x is positive and the y is negative. So this is my terminal point for t, for 7 pi over 4. Any question for this one? Okay, so the section is finished up to here. And any question for the section? Okay, let me give you exercise, a small exercise. Just the third one is exercise here. Number 3, for the same question. Find the terminal point for t equal minus 2 pi over 3. Okay? I'm going to stop up to here. Thank you so much. Any question before I stop the lecture? Okay. See you next time.